Hello retro nerds! It's been a while, hasn't it? I felt it's time for a new video, so here it is. As you can see, we have a Sega Mega Drive 2, or Genesis for some of you, which seems to have a bit of a problem with its video output. It's all pink. Let's see what we can do about that. Now, before we get started, let's take a look at the potential sources for this problem. This is a block diagram from the Mega Drive service manual. The stuff we're interested in is all this section up here. We have the video display processor, which is responsible for generating the signal in the first place. It outputs the RGB signal to the RGB encoder, which turns the basic analog RGB signal it receives from the VDP into something the TV will understand. From there on, not much more happens. The signal goes to the video connector on the back of the Mega Drive, and the RGB cable connects it to the TV. We can rule out the TV as the cause for the problem. I use it regularly and it just works fine. The cable would have been the most likely problem, but I tried a brand new one and it didn't change anything. Also, I guess I wouldn't have made a video if it was just the cable that needed replacing. Now that we can rule out any issues on the outside of the Mega Drive, let's open it up and take a look inside. These 9-pin mini DIN plugs take quite a bit of force to get into and out of the jack. Each mating cycle puts stress on the contacts and, even more importantly, the solder joints. So the very first thing I did was reflow the solder joints, just in case tiny fractures in them caused the whole issue. Sadly, that wasn't the case, so I decided to replace the jack instead. I could have gone and gotten out my cheapo oscilloscope and checked whether the green signal was still okay all the way to the video jack, but those jacks are nearly 30 years old and have probably built up quite a bit of oxidation and other grime, besides probably having worn out contacts. Replacing them would be a good idea anyway, so before I tried anything else, I did that. It took me quite a while to get the old jack out though. Removing all the solder, especially from the mechanical support pins soldered to the ground plane, wasn't quite as straightforward as I had hoped. The ground plane slurps up all the heat and doesn't leave much for the solder to melt and stay liquid. But in the end I succeeded, even if I had to break the old jack apart and desolder it in bits. With the old jack out of the way, I could finally get to clean the pads and put a new one in. This half of the process is usually a lot more straightforward, and this time is no difference. Done! Plugging it all back in, turning it on, crossing fingers, and it works! We had a bad video jack, that's good. Neither the VDP nor the RGB encoder are still being made, so finding a replacement would have meant looking for another Mega Drive with a different failure. Even a broken trace in the board would have been a pain to repair. Not that getting this jack out was a pleasant experience though. Alright, that's the required work done, but I wouldn't want to give the machine back to my brother-in-law like that. Let's make sure it survives the next 30 years. It is a custom and retro hardware refurbishing to replace those decades-old electrolytic capacitors. Their characteristics change over time and deviate more and more from what the engineers needed in there. This is one big recapping session though. There are no less than 31 electrolytic capacitors on this board. So while this isn't a particularly difficult task, especially thanks to my desoldering station, it still took quite a while to take them all out. And as always, when desoldering old components, they can have too little solder on them for the desoldering gun to really get into good enough contact with. Or maybe there's some oxidation or dirt in the solder that prevents good heat transmission. There's a simple cure for both those problems, and that is adding a bit of fresh extra solder before trying to desolder. Also, sometimes I turned on the pump too early, before all the solder in the joint had melted. In that case, there's usually enough left to hold the pin in place, but not enough to make contact with the soldering gun with again. The solution in that case is the same: add a bit of extra solder. I had to do that in almost all joints. Without all the capacitors in the way, this is also the perfect time to clean up the board. An anti-static brush and some compressed air got rid of all the dust that had built up over the years. All that was left was to get the capacitors back in. Again, not a difficult task, just one that takes a while thanks to the sheer number of them. It also makes sense to go a bit slower and double check you got the right capacitance and voltage ratings, as well as the right polarity when putting them back in. We don't want to break anything now. It helps a lot to do the caps and batches of the same capacitance. That makes it easier to focus on the other factors. Making a list of what goes where before desoldering is the key here. This is especially useful if we can't be 100% certain about the service manual being really for the same revision of the mainboard, or in cases where we don't have the schematic to begin with. And that's the capacitor replacement done. Quite the tedious task. It took me about an hour in real time, but I think it's worth it if it means the console will remain usable for longer. Another thing that does occasionally break, especially when it gets old, is the 7005 voltage regulator. This chip takes the 10 volts the power supply provides and turns it into a nice stable 5 volt supply voltage to power all the components in the machine. These linear voltage regulators can get pretty hot because they essentially turn the difference of voltage between the input and the output into heat energy. This heat needs to get removed from the chip, which is why I usually find them screwed or clamped to a heatsink. The Mega Drive is no different here. Its heatsink is a bit annoying to work with because it involves bending metal nibs back and forth to replace the regulator IC. So step 1, desolder the IC's pin. Step 2. Bend the metal nibs out of the way. Step 3. Pull the 7005 out from the top. Before putting the new one in, I added a bit of thermal compound so it can make good contact with the heatsink again. It helps to push the new regulator down as far as possible at first. This allows bending the metal clips back into place before pushing the regulator back up until it's held firmly by the clip again. Then we just need to solder the 3 pins and clean up any mess we made with the thermal compound. We've made many repairs to the board now, time to test it again. There are so many things we could have done wrong, fingers crossed. But it all still works, no fires, no exploding capacitors, nice. Now if you've watched any of my previous videos, you know that I like to give these old machines a good clean. This Mega Drive deserves a nice warm bath too. For that we first need to take the rest of the case fully apart. The cartridge slot cover mechanism is a bit finicky, but nothing a bit of patience couldn't solve. Ah, warms the water. While the case has its once in 3 decades bath, we have time to clean the RF shielding and controller ports. The case has soaked for quite a while now, time to get out the elbow grease and the toothbrush to get it all really clean. Before reassembling it, I gave it about a day to fully dry. There was some leftover dirt in the power and reset button slots, time for more elbow grease, some alcohol and a Q-tip. Unsurprisingly, reassembling the cartridge slot cover was even more finicky than disassembling it. But in the end I succeeded and could begin with the very satisfying process of putting it all back together. Did I mention it was finicky? An important thing to keep in mind when reassembling old or new plastic cases is to take care not to destroy the threading. When fastening a screw, first turn it counterclockwise until you notice it clicking into the pre-cut threading. Omitting this step will ruin the case in just a very small number of closings. And that's all! Another retro machine repaired and refurbished. If you made it this far, thanks for watching and see you next time. Bye!